Hello again. So we will continue from where we left off. Um, I finished the video by saying we're gonna make the Pyro simulation, but I guess we can finish the part where we're gonna do the instancing, so we can get the size between the big rocks and the particles. Obviously, that needs some filler geometry in between artistically. So that's what we can do now. Um, and then I think we can prepare this in a way going into our debris simulation that we cached out. Let's hide this. So we have this particle cache that we cached out. So let's grab some of those particles now and attach some rocks on it. So let's drop in an attribute delete to do a little bit of cleanup. Let's keep ID, let's keep velocity, let's keep the CD. We don't need really the CD, but we can use that for shading purposes, passing on, just in case. So let's drop in a wrangle because we don't want to copy everything, but we want to keep some percentage, so we can say if ID modulo 90 remove point myself at pt none, and this should remove but then not change every frame, so we don't get like it's always keeping the same amount of same particles, 10% of so that's 1839, which we'll do copying on. Well, we can use the color that we already have for defining the scale, maybe. So let's say p scale equals at cd red channel, let's say, times, let's open up a channel ch, let's call it mult, okay, and another, and then if you press this guy, with this being present here, it's gonna create a slider. Let's give it a value now for now, and now let's go a basic copy stamping, just so we can see the size. Okay. Now obviously we don't want spheres, so let's go some polygons, low res. Let's drop the mountains up, and ideally we can also do the same thing that we did for the 3 instancing. So let's do that. So on the world center, let's create some nicer rocks, right? So how can we get a nice rock shape? I'm not sure. We don't need that to be so neat at the moment. Okay, but maybe like this, and if you change the time, we get different variations. Alright. Or offset. Okay, so let's do the offset. Let's give this guy a normal, and I want the hard normals. Okay, and let's give this guy a UV just in case we decide to make something pretty out of it. Okay, maybe a UV unwrap. Oh, that's really ugly. Well, we can try spherical, polar, cylindrical. Okay, oh, so we don't need that. Let's just put it a U. Alright, that should be fine. So we have UVs as well now, and we have a rock. And what we need to do is that how many of these do we want? So let's put a file cache like we did before. Let's call this rocks. That's, I think we had that 3 library, so let's create a new folder called rock library, and we just put a $f in there, right? That's how I remember it. Yeah, okay, so let's select this guy, rock library $f.bgo.sc. okay, that seems legit. And let's go from, was it from 0? I think it was from 0. 3 library, yeah, let's go 0 to 50 again, and let's hook up the $f to here and maybe here, I don't know, doesn't matter, just gonna create different variations every time we scrub. So it's gonna give us 50 different variations of rocks of very similar size, but then now we have the RP scale to deal with it. And let's save the disk, and done. It's not gonna read obviously because it's not in the correct frame range, but our cache is here, 1.60 megabytes, which means that if we use disk-based instancing, this is if you use each 50 of them, the footprint will be much less than just having everything copied 10 times. So it's not going to, if we instance 500 objects randomly, we're not going to use 10 times more memory because it's instancing, right? So now what we can do here is that we create our, again, random value. So I think it was we need an ID equal object ID or any attribute actually. So then we need to fit a random, right? It was like that at ID. This should, one second, let's go step by step. Okay, where is the object ID? This is because of float, right? Okay, so if you go float, okay, and then let's fit this in. So that's 0 to 1, and then 0 to 50. Where are missing? No. Random ID. Oh, sorry, here. Okay, so that's gonna give us an object ID 0 to 49. Let's go 51 and let's floor this. Okay, and then we can say I. It's gonna convert this to 0 to 50, and it should be quite random if we line up the particle, sort by ID. Okay, so we have this guy now here, so let's call this random scale underscore object ID. And then let's create our string for creating instance paths. So this is how we were using it, as at instance file equals sprint f open parentheses, and then we write our path, right? So which was like that. Okay, and then I want to use I at object ID attribute where I see $f %s should now give me, like before, all these nice paths. So then what I need to do now is that I can put an instance up here if I want to visualize those guys. And if I'm not seeing anything, okay, let's update that as well because it needs that guy. And okay, so different size, different color. Okay, something is funky. Why are my normals shifting? Or are they? They are. Do I have normals here? My color is shifting maybe? Yeah, my color is... Okay, we need to check this. This could be a report issue as well. I'm not sure what's going on. Okay, let's try on the camera view to see. We have the normals here. Oh, I don't see. Where are the normals? Oh, okay. Let's try this. I don't think it's related, but let's give it a go. Well, I'll be damned. Okay, it was the... But, no, I think it's the... Something is changing, and I'm not sure what. Okay, let's... The color seems to be changing, but no, it's... The wireframe is shifting. That's very strange. Okay, let me get a new scene view. Okay, just in case. Hide others. And all the textures, no lighting. Okay, this is very strange. We get some flickering, but it's the objects are sticking, and we get... I don't know. I'm just gonna say that this is a viewport issue somehow. Okay. Yeah, I think it's a visual thing. It was the wireframes flickering or something. Let's try to see it a bit bigger. Oh, okay, so it's working in a way, but then we get particles disappearing because of their short lifespan, which I haven't taught all the way apparently. So what we are gonna do is that we're gonna catch this guy out again, because we can't have rocks disappearing in the mid-air. Oh no! Okay, let's see if we can recover this crash file. And because we can't have things disappearing right in the mid-air. Okay, where is it? Delete tab. Okay, let's try. And then we can say, yay! Okay, let's save to our project folder. Production oriented. I'm still going to save same file because it's still a part of it. Okay, and let's go again. Let's put on manual. This simulation starts at 1076 anyway, and let's load it to this frame. Our camera, okay. So let's give these guys a long lifespan. Originally it's 100 frames. Okay, let's cache that out now, and then as soon as that's over, actually while this is running, we can run this in the background and then move on to the next thing, and then we'll come back to this. No, go version 2. Every time you change something, you need to save to run anything in the background, basically. Come on, alright, save disk, scheduler, this will do its thing. So then, while this is running, let's move on to our second, the actual task in hand that we spoke to do, which is the just for refreshers, this first volume that runs all the way. So to do that, we're going to create a new geometry. Let's call it ship smoke or pyro or anything you like. Let's just give it a simulation color that we're making a simulation. Okay, so a good simulation requires a good source, right? So we need to create a cool source for this, and because everything is animated under animated ship, and we're fetching everything there because this has the keys, I'm gonna create my source under my static geo. Okay, which means we go into our ship folder, and then let's drop in a point. Whoop. Okay, and let's create some noise in here. Let's create 2 turbulent noise. Turbulent noise 1 with the values 0.1, 0.1, 0.1, alligator noise, position to position. Okay. Roughness 0, 1, amplitude 1, attenuation, turbulence 5. Let's copy paste this guy, create another random value. This time set the frequency back to 1. Amplitude to 3.4, roughness to 306. Okay, and then let's create a ramp. Let's hook this up, and then multiply the output of ramp with turbulent noise 2, and pass that on as CD to our ship geometry. So if you look from here, now we should see some color variations. Yeah, this is our noise. Okay, and now I want to see that if we have normals, we have normals, but I'm going to create point normals. Create a normal in the swap, switch the points, and then let's do a little scatter. The default relax iterations is on, that slows down things. Let's put 60,000, and then we want to use density attribute to be CD because we want to use those colors as emission points. And okay, and then let's call this, let's give it a null. Let's call it out generic PT's point source. Okay, this now is scrubbable, it's not doing anything. Okay, so now let's object merge this in our ship smoke. No, geometry here, object merge into this object, and it was the ship, generic. Okay, so now what I want again is possibly well, since we already animated this, but then we want to animate it from here, otherwise the points, well, but basically if we put this here, because it's after because we're using the position based noise, but then if we shift it around, the noise will shift as well, but I don't want that. So what I'm gonna do is I'm going to create a reference copy, and then I'm gonna cut it. This should work if I carry it onto a different geometry. If not, I'm gonna make a ticket. And no, it doesn't work. Okay, we should just copy that then. Where were we? It's going here. I'm just gonna copy this guy. Well, we can just do this actually. Let's go back in here and let's just put this here. Well, we may want to use this for rendering, so let's create a reference copy and put this guy here. Okay, so this way our points will be transformed much faster. Okay, so let's go in back in the ship smoke, and let's create another. Well, now we're going to utilize these colors to create our source values. So let's create a, so let's call it create temp fuel vals. Let's dive inside. Let's create a turbulent noise using position. So I want the noise to shift where the emission. I don't want to shift where the emission is happening from, but I want to shift where the amount is. Well, there's one thing we need to clear out, is that we obviously don't want to emit stuff from the antennas, since our transformation is after our scatter done, so we can literally hand select these guys, and it shouldn't cause a problem even if the spaceship changes position. Okay, so let's delete these points. Okay, so this should, okay, so that's good. And so we're creating a turbulent noise. Let's promote frequency, offset, and amplitude, so we can have an easier control from outside. And I want to multiply this noise by my color, and then I want to overall multiply this with an attribute called emit amount. Okay, so let's just create that. Now what I want is this value to be exported out as an attribute called out fuel, and I'll call it as an attribute name fuel, and it's here now, and we need to, okay, it's set to 0. Why? Oh yeah, because my emit amount is by default 0. So let's give the proper value. So let's if we multiply if we change the frequency to $f every frame, we're gonna have our noise shifting. And let's change the frequency. Sorry, let's this should be an offset X basically, and let's actually copy that to YZ also. and then let's change the frequency to 0.9, and then amplitude 6, emit amount 5, and then go back inside so we can finish the rest. And then I want to do a little normal push velocity, so I'm going to multiply the normals, which is coming from the ship's surface basically. I should be pointing outside, yeah. And then I want to multiply that by this product of multiply 1. So if I and then I want to have another control overall speed of this, and basically I want to multiply this with another value so I can define how much I want to push this out, if there's a flame coming out and if it's shooting out or not, based on how much source there is, based on the color also. So then this one I want to be my velocity, okay, which should translate it here after we put a value to it. And then I also want to copy paste this and then call it out temperature, and then temperature. Okay, so now we have and the only thing remaining is to put the velocity multiplier to 1, and if we look at this guy here, it should draw us this tiny vectors based on color and normal, based on normal multiplied by the color. So it's just to randomize our emission a bit stronger. Okay, so the other thing I want now is to create a bounding box, basically, to define the maximum size of the simulation I want. I think we may or may not want to use that. Actually, let's leave that to later. So let's give this a null now, because we have our points, we have some cool values we can use for the Pyro sim to inherit. So let's call this out Pyro source. So now we need to create a .NET to start our Pyro settings. Let's call this ship smoke column irs. Well, or just call it dop ship smoke column. Okay, let's dive inside. Here now it's gonna be a complicated one. Okay, so now we're gonna do this from scratch. Basically, we're gonna create a smoke object and call it fire or smoke, whatever. And I want to create a pyro solver. So that goes there, right? And this goes here. So I want to source, and I want to, so basically the second input I want to create an auto resize, not auto freeze, resize, that gas dynamic resize that goes in here. That's pretty much the raw settings almost from the shelf tools almost. So I want to create a collision object. So I want to bring in a merge here, a static solver, static object, static solver, that goes here, that goes there. But pay attention to merge one, that left input affects right input. So now that's not the order we want, so switch like that, and this is gonna work now. And let's call this static object name ship, and we will need to bring in the animated ship to subpath, because we don't want to calculate the shape every single frame. So let's bring in animated ship. Where is it? Animated ship. Okay, I think we can go in there as well. There should be an out animated ship. Okay, there's too many things, so we need to go and see what is there. We want the geometry for this. Okay, so we have the file one. Let's put a null here. Let's call it ship out ship geo. So that goes in to the static solver part. Where are we? Here, here. Ship, automated ship, out ship. And then under the collisions, volume, proxy, we want to get that VDB shape in here under animated ship. Where are you? VDB. Actually, let's give it a better name. Let's call it out collision VDB. Okay, and then the next thing we want is now to set our start frame, I suppose, and this time we need a pre-roll, because we want to cut into a frame where there's already fire. So let's extend our frame range, and let's change our start frame of our .NET to 900. Let's go to 900. Okay, let's go in. So now let me reset that. Okay, so obviously nothing will happen. All we are seeing is the collision geometry, and it's not even moving, but it should be moving. Maybe we need to set the use object transform, I suppose. Yes. Okay, we're not moving. We should be moving. Okay, let me check that. Let's go to alt ship geo. Animated ship. This should be moving. Let's hide these guys. Okay, let's go back in ship smoke. Object transform. This is correct. OBJ path. Yeah, well, we're missing this guy because it's object transform. And yeah, it's moving now. Okay, that's good. So right now it's just utilizing, it's just showing us yep, geometry is stuck everywhere. Okay, let's get back to this guy. And let's hide the terrain. Okay, so for this shot we start with this camera. Okay, that's 2A, and let's get back inside the ship smoke. Here now we're gonna see the geometry moving. Okay, that's good. Now we need to initialize our particles. So for that to work, we need to bring in those particles into the simulation, and in order to do that we need a swap geometry swap. And we're gonna plug this guy here, and we're going to write in the swap path up input path, up input path, open parentheses, dot dot 0, and yeah, backtick. So that's gonna bring in the first particles, whatever is coming into the first input, basically. It's a 0. Okay, and then we can name it here whatever we want. Let's call it source PTC points. Okay, and now we need to attach this data by using apply data. Apply data, and it works like that. And then now we have the particles in the simulation scene, and there are a few things we need to define. At sub geo we need to tell these guys to move, so we need to tell them to be always available, so it will update. Otherwise I think it stays on the first frame. Yeah. So we set it to set always, and now the particles are in, but we still have to tell Dini what to do with them, and that's gonna work by us attaching this information as a source, as a pre-sol. So how does that work? Let's create a merge here. Let's create another merge here that goes into this, and now let's create gas field to particle, and let's call this gas field to particle fuel, and I want to source fuel. I want to assume, okay, this is the wrong one, sorry, it's not gas field to particle, it's gas particle to field. Let's call it again, gas particle field fuel, and so the particles, because we renamed this, remember, we renamed to source PTC, I need to be matching names. And I want to initialize fuel and export that out as a fuel. I can assume uniform radius, unless you have p-scale, different values whatsoever, and change the calculation to additive source pre-malt to 0.5. Basically this is just my settings that I know that is going to kind of work. I think that's it for fuel. Let's copy paste this guy now. Let's call it temp, and let's do the similar things here. So I want this time my values coming from temperature, and this is same, copy paste temperature, again the same place, assume uniform radius, extrapolated, additive, and 0.5, same. We can possibly change these values if needed, key the amount, or hook them up to some other parameter. Copy paste the temperature again, but this time we're going to create density because we want thick smoke. Density, it's going to be created from fuel because we don't need to create additional density information. I want a lot of smoke, multiply by force, additive again. I think that's pretty much it for this part, and now what we need to do is to figure out our bounding box. There's a little offset here which we need to figure out where that's coming from. Could be a little offset somewhere which we have to figure out, but let's get back to what we were doing. So now what I want is that wherever I move this object, I want the containers bounding box to be initialized automatically. So let's get this guy and let's get this information in here for the initialization frame, so you don't have to worry about manually moving the container every time you need to every time you get an updated position. So in order to fetch that info, we can go bbox, open parentheses, and go find our node that we are trying to fetch the information from, and after close brackets, double quote, is that how you call it? Okay, and then d underscore x size, but I also want this a little bit bigger. Okay, and then copy paste this time it's y size, tab, and then z size. And now we need to figure out the center. Then it's the centroid of exactly what's on top. So that works by saying centroid, open parentheses, find out object, which is the same one on Pyro, and close, not comma dx, as you can see it's giving us an example, d underscore x. Okay, and this should give us a centroid, copy paste y, tab, paste z. Okay, now where is our container? We need to figure out these values as well. I don't see any smoke. Why? We're missing something. Our bounding box. Okay. I want my auto resize to track. Oh, we are missing. Make the mistake here. The y and the x. Okay. And then I want my resize object to follow this guy. If I press play, we have smoke. We may, but I think our initial resolution is too high. Well, let's go 1 for now. Zoom in, press play. Alright, we have smoke. Cool. It's not it's not doing anything what we want, but starting from scratch is a pretty good progress. Let's go to gas recite fluid and then increase the padding, and let's go to max bounds. Let's go from object, ship smoke max size. Do we need to do that? Let's try. I don't want, actually. I want this to be naturally dissipating. Well, we can define a max bounds and then attach that. Could come handy. Okay, so obviously right now it's just a big blob, and we want it to be better than just a big blob. So let's start playing with some parameters. What we didn't bring in was also the velocities, which we can add in as well. So let's start by, actually we can give, we probably need the wind just to make this a bit more interesting. Our ship is always flying toward z-axis, so we can probably just add a gas wind, which I did actually in my scene anyway, and hook that up to velocity update, and then the default values are probably, it's gonna blow on X, it's gonna blow a bit sideways. Let's just play to see what it's gonna do. just to make it a bit more interesting, I suppose, which we can play later on. But let's do the Pyro solver settings now. So on the simulation, I changed the diffusion to 0.4, cooling rate to 0.8. I have a buoyancy of 1, time scale is left off. Under combustion, ignition temperature is set to 0.01, burn rate is 0.95, fuel efficiency is 0.1, temperature up is 10, gas released is 2. And then under flames, I have flame height of 2, and under smoke tab, I have great dense smoke amount set to 2, and then under fuel, I turned on advec fuel and my value is 25. Then under shape, I have a very high dissipation of 10. I have a disturbance of 10, a turbulence of 3. Under disturbance tab, I have a block size of 2, cutoff is 0.15, but I'm using use control field, and that's ran by temperature, and control influence is 2, and control range is 1.2. And then I also remap my control field, and I select these handles, change them to spline, and then let's create another object here, set the value to 0.52087, exactly my value, 0.04190048. Okay, this is kind of like remapping, and then going to the turbulence field, swirl size, big swirls, it's a big ship, 0.6 for grain, and then again, not density but temperature. Again, remap control is modified. This time spline again, but then this value is a bit different. It's at 0.77185, 0.0133333. Okay, so that's my turbulence settings. Everything else should be pretty much default. Now let's work on the visual part of it a little bit. And under visualization, on smoke object, turn on multi-field, go under the multi-field, and then let's put the density to 0 for now. Let's type density in case we want to see density, and then diffuse field density as well. And then under emission, type temperature. Let's put the emission to 0.5, and let's put this guy here as well. Let's press play. We should see some fire and some noise and all that jazz, and some bursting. But is it doing the right thing? It's a bit too much maybe. Well, this is still the pre-roll, it's gonna stretch, so we can see that if we increase something like that, we can get some dense areas. Let's play with the density maybe. Okay, we're gonna play with this after. So the other thing that I find out was that I was keep getting ranging numbers in terms of density. It was just sometimes getting too much, too little. So I want to keep that in control, so the shading part wouldn't give me a lot of difficulty. So in order to do that, we can drop a gas field wrangle, and I don't want to emit, I want to clamp my density. So if it passes certain amount per voxel, I want it to stay that way. So I'm going to clamp the density field by using a gas wrangle. So F at density, clamp, F at density, 0 to 20. Okay, so it's never gonna get denser than 20 units per voxel. Okay, if I press play now, I think it's already working that way. Let's try to get some. Okay, so that was it, 5, and let's put this here too. We'll put that back later. Okay, so now I want to make sure that my collision is also working. So what I'm going to do now is that I'm going to select the ship because we didn't affect this part properly. I want to, for example, if I turn the display and then turn on collision shape, and as you can see it's not working at the moment, so let's switch it to by size, and by size 0.5 is fine, mode, volume sample, and if I turn this on now, it will use that VDB to create a single frame version of my collision object, which we can obviously go higher or less, but for now we're going to leave it as it is. And now I should get proper collision as well. So this is quite low res at the moment, so let's go a bit high res. Let's go 0.2 and press play. Okay, we need, let's figure out this the gap, and then we can do a play blast. I keep saying play blast because I have a Maya background as well, which I used for a long time. Let's make a flip book, but let's figure out the difference first. Okay, so where is that difference coming from? Use object transform, animated ship, animated ship. This is very strange. This guy is here, which is this guy, and then okay, so there is a difference somewhere between this guy and this guy. There is no transform whatsoever. Okay, alt ship geo, alt generic PT source, and it's ship. There must be a difference between these two. Okay, well, I select something. Come on, waiting for vegetation to calculate. Okay, there is obviously a difference between ship and animated ship, which we'll find out right now. Okay, let me put this on manual to avoid extra calculation. 146. 146, 146, 823, 146, 823. Okay. Oh wow, thank you. That's a bit surprisingly strange. So if this guy here, this guy, what is the difference? I am not. Pivot translate. What is this? Excuse me. Oh, there you go. Okay, so we moved something somewhere, so you may not actually face that somehow. Okay, let's go in here. So now it should line up appropriately with this guy, and so it seems to be okay. Cool. Let me try something like that to see what's going on. In order to check if you have the collisions working, the easier thing to do is to the easier thing is that you can, because it's all custom work, right? So you can go back to the visualization, turn off multi-field, turn on collision. If you press play, let's hide the our collision, our geometry. So that's actually what is being collided. So it's kind of working. I guess we can improve that a little bit by giving it a little bit of a offset. Let's put 0.01. Let's press play. I'm not sure if it made any difference. We may need to use a better collision object, but we just want, let's say there's some smoke inside the ship as well. Why not? So that should kind of give us a bit interesting result, nevertheless. 1 second, let's change these settings. Okay, let's press play. Okay. For now, this seems to be working. We can do a little bit of play blast to see what's gonna. Okay, that's what's 0.5 actually. And let's go back to our camera. And I'm going to pause the video. I'm going to save and pause the video and make a play blast, a flip book, so we can, if all seems to be working, we can set up the caching and then send it for caching. Okay, so let's go flip book, 900 to, I think we want, for this camera it's to 1080, but we're gonna do a lot longer cache. But we will have to adapt based on camera distance to do several different caches per shot. Okay, start from 900 to 1080 and play last. Okay, so the flipbook is finished, and this seems to be working. And I'm going to cut the video here now, and I guess in the next lessons we're going to start we're going to finish the instancing that we started in the beginning of this lesson. So what we can do in the next one is then to start actually the FEM solid solver simulation, the last part of our cache of our tutorial, and then basically, let me see, by that I mean, that's, to my taste this feels a bit too fast, but I guess we can speed it up, slow it down, but that will be another part. So I guess we can now focus on this simulation here, which is, I don't know if it's here. No. Okay, so we're gonna start on the solid simulation, and then from there we can move forward to setting up the Pyro settings, and then populating all the other shots with this setup that we created for this camera, but then we can always use high res, lower res settings for other cameras, which we're gonna cache out and put on the side, and then from there forward we can start shading our scene. Okay, thank you for watching.